suppose when Earth was created, it was not rotating. However, after application of a uniform torque, after 6 days, it was rotating at 1 revolution per day. What was the angular acceleration during the 6 days? What torque applied to the Earth during this period? What was applied to Earth during this period? What force tangent to Earth at its equator would produce this torque? Okay. So, by the way, so for a solid sphere, the moment of inertia about this axis is 2/5 mr squared. Okay, so we'll need all that formula. So now let's find out what was the angular acceleration. Okay, so part A, the final angular velocity is 1 revolution per day, which is equal to 2 pi radians divided by 1 day is 24 hours times 3,600 seconds. Okay, so okay, so the angular speed of the Earth right now is 7.3 times 10 to the minus 5 radians per second. Okay, that's the angular speed of the Earth. Well, so 1 millidegree or 4 millidegrees per second. That's what that translates to. Okay. Now, what is the angular acceleration? So, angular omega is omega naught plus alpha t. Alpha is omega minus omega naught divided by t. So, you have 6 days to get to that. Start off from 0 to get to that angular speed. Okay. So, alpha would be, you're starting from rest, so that's 0. That is omega is 7.3 times 10 minus 5 radians per second, and 6 days, so 6 into 24 hours into 3,600 seconds. Okay. So angular acceleration is 1.4 times 10 to the minus 10 radians per second squared. All right, what torque was applied to the Earth during this period? So that was the angular acceleration. Part B, torque is I times alpha. So let's calculate I for the Earth. 2/5. Somebody look up the mass of the Earth. I believe it's 6 times 10 to the 24 kgs. But can you look it up? Okay. And radius of the Earth is 6,400 kilometers. 6,006.4 into 10 to the 6 meters square.
Yeah.
What?
Yes.
Okay. And so let's take your powers of 10. That's 12 plus 24, 36. So 2/5 into 6 into 6.4 square. Yep. So moment of inertia is 9.8 into 10 to the power 35 kg meter square. So the torque you need to apply is I times alpha, which is 9.8 into 10 to the power 5 kg meter square times alpha was 1.4 into 10 minus 10 radians per second square.
So 9.8 times 10 to the 5th or 35th?
Yeah. What's 10 to the power 30 between friends?
Quite a bit.
Huh?
Quite a bit.
Quite a bit. So this is the torque you need to apply to get this Earth spinning to 1 revolution per day starting from rest. Okay. Now what does this, so again this is a, what force tangential to the Earth at the equator would produce this torque? So what part is this DC? Okay, so here is the Earth. You're applying this force tangent to the equator, and this is a top view. So torque is F times R, force is torque divided by R. So 1.37 into 10 to the power 26 Newton meter, and the radius of the Earth, remember, is 6.4 times 10 to the 6 meters. Okay. Oh, we have another problem. Shoot. All right, so this force works out to 10 to the 26, that's 10 to the 20, and 1.37 divided by 6.4. Okay. And so this force, just to give you guys a sense, 10 to the power of 3 newtons is the weight of one person roughly. I mean, a heavy person, but anyway. So 10 to the 16 people, the weight of 10 to the 16 people, that kind of force you need to apply. 10 to the 16 people is 10 million billion people. 10,000 trillion people. You're making the problem worse. You need another 100 times that many people. Is this correct? That's correct. That's correct. That's 12, 36. Yeah, 37. What happened here? All right.